Hello and welcome to Diplomatic Derivatives. In this series of lecture, we're going to talk about applied mathematics. We have already covered one video in terms of position vector in applied mathematics, so make sure you check that video out first because the concept of position vector is explained in that video. And here we're going to start with exercises related to position vectors. So let's see what are the questions. We're going to start with basic level questions. Question number 1. Given the following points, write their position vectors in terms of I, J, and K. So you've been given 3 points here. First point is A, then B, and then C. Now these points are representing a position in space. So it can relate to a location in space, and then you have to provide a position vector which is going to start from the origin, of course, and it's going to let us know where does that point exist in space. Alright, so we are basically trying to locate the point, and that's why we use position vectors. So when the question asks write the position vectors in terms of I, J, K, it means that I is representing the x-axis. These are the unit vectors. So I represents x-axis, J y-axis, and K represents the z-axis. It comes when we talk about 3D. Okay, ij is for 2D and k is for 3D. This was just a slight recap for the previous videos. Now we're going to make the position vectors, and these kind of questions, make sure you draw the position vector or draw the vectors in space. It's in the Cartesian coordinate system, so that it's easier for representation also, and also will earn you marks for that. All right, so we're going to start. We have point A, which is 3, 4. So it's located from here. We can directly see it's in x and y. Okay, so 3 represents for x and 4 is for y. All right, so when you can draw A, so you can see here, first what you'll do is you draw the x and y axis. We see 0 here, so it starts from 0, and it's 3 on the x-axis, so you got 3 points, and then 4 on the y-axis, so that's the point over here. And you draw the line from starting from 0, so the tail of the vector is from 0 and the head is at that point. All right, this is the vector. Okay, similarly for B, so B, if you can see, it's 3 points, it's in 3D, right? So in 3D, that's how you see that B goes 1 point on the x-axis, minus 2 in the y-axis, it's in the negative, and 5 on the z-axis, so it goes in 3D. Okay, then we have C, which is minus 2, 0, and 0. So we see y and z are 0. We only see the representation in x. So from 0 you go to minus 2, and we have a straight line here because y is 0. Okay, so this is how you present C. Now how to write the position vectors? A will be what? 3i plus 4j, then B is 1 will be I, then minus 2 becomes minus 2j, and 5 becomes plus 5k. Then C is minus 2i. If you have 0, 0, and minus 2, it will be minus 2k. Or if it's 0, minus 2, 0, it will be minus 2j. Right, that's how you will write it. Yeah, and also make sure that you put these caps on top of the unit vectors. Okay, I just missed them in the slide. Okay, so these are necessary. All right, otherwise the examiner will cut your marks for that. Okay, so this is a very simple question. It can come in MCQ as well, just to point out which is the position vector for the given point, right? Question number 2, given points A and B, find the position vectors of A and B with respect to the origin. So you have a point A, which is 2, 3. So you can draw on x-axis 2 and then y-axis 3. That's the first position vector. And B will be on y-axis, x-axis 5 and y-axis 7. So that's the second position vector. So you have to draw it with respect to origin, starting from the origin and towards the point is the vector. So it will be A will be 2i plus 3j and B will be 5i plus 7j. Okay. Next, question number 3, find the vector AB if A is 2 minus 1 and B is 5, 3. You have to find the resultant vector AB. This vector is OA. according to the position vector. And in the previous slide also, the question that we did, when it's from the origin, the tail is at the origin, so that is point O, and towards the point, that's point A, so the vector will be resultant, the vector itself will be OA, right? Similarly, when you're making this point vector A, which is 2 minus 1, so you can take 2 here and then minus 1 here. So this is the first vector. Okay, this is point A. It's in the negative in the y. Okay, and then you have 5, 3. So you will have 5 points on the x-axis, that is still here, and then 3 points on the y-axis. So this is the point. So this is vector, this is O B. Okay, so basically what they're asking is that this is OA, this is OB. You have to find vector AB, which is from the tail of the first vector to the head of the second vector. That is the head to tail rule, and we have done one video on that as well, so check that out as well. I will give the link in the I button above. This is a very important method, which is the head to tail rule, okay, to find the resultant vector. So basically AB will be equal to B minus A, that is OB minus OA. Okay, so it's better to write OB and OA. So this will be OB minus OA. Okay, so it will be OB is what? 5i plus 3j minus 2i minus 5 minus j. Okay, so the resultant will be I will go together. So this will be done with this and this will be done with this. You will solve it. So you get 5 minus 2 is 3 and 3 minus plus. So 3 plus 1 is 4. So you have 3i plus 4j. And always remember that you have to write the answer in the way the question is given. So the question is given in points, so make sure you write the answer in points as well. If the question was given in vector form, you write the answer in the vector form. Okay, so here it's in points, so you will write 3i will be 3 and 4j will be 4. Okay, if it's minus 4j, it will be minus 4. All right. Next, question number 4. Find the magnitude of a position vector OA for the point A minus 6, 8. You have to find the magnitude here. Again, for magnitude, we have a formula. Also, remember to make the diagram, so it's all going to earn you bonus marks. All right. So O starts from the origin, and then A minus 6, 8. So minus 6 on the x-axis, you come minus 6 here, and 8 on the y-axis. So here is where you get your point and the vector. Okay, you have to find the magnitude of this. So the magnitude formula is root of a1 square plus a2 square. That is the first number is square and the square of the second one. Add them together, take the under root. That's the magnitude. So it will be minus 6 the whole square plus 8 square. So you are going to get 36 plus 64. Take the root of 100, you will get 10. Okay, so the magnitude, which is represented in this manner, is 10 of this position vector. Okay, now we move on to, we will just increase the scale of our questions. So just going to intermediate level of questions. Given points A12 and B46. So first draw A12. Okay, so this is the red one is A, 1 on the x-axis and 2 on the y-axis. B46, so it will be 4 and 6. So that's the second vector from the origin to the purple one. Okay, that's B. Find OA plus AB. So OA, which is this, the red one, and AB, which is the resultant. So resultant is from which point? Okay, I will just write here. This is O, point O. This is point A, and this is point B. Okay, and this is the resultant. Okay, which is AB. So you have to find OA plus AB, and then you have to verify that it gives OB. So in the question that we did already, we saw that from the head to tail rule, AB is equal to OB minus OA. So we're going to use the same formula. From that, you will get from OA. So before moving on, we'll just write A is OA, which is I plus 2j, and B is OB. So it is 4i plus 6j. Now we know this formula already, which is AB is equal to OB minus OA, the head to tail rule, right? So OB is what? 4i plus 6j minus OA, which is I plus 2j. So you're going to get 3i plus 4j. So you have AB now. Okay, this is the value of AB, which is 3i plus 4j. You have to find what? You have to find OA plus AB. So you have OA, now you have AB also, right? So from this equation, right, what can we do? We can get OA plus AB, right, which we need, which is a question. So take OA on the other side, so you will get OA plus AB, which will be equal to OB, right? This is what we have to verify also. So now you will solve it. So OA you will put I plus 2j, AB you will put 3I plus 4j, which you got from here. So you will get the answer, which is 4I plus 6j, which is equal to OB, hence verified. Okay, that's how you solve this question. These kind of questions are expected in examination also. So it's a very simple question by just using the head to tail rule, which you have to remember. Okay. Also, since the question is given in points, so make sure you write the answer in points as well. Okay. Next, we have find the unit vector in the direction of the position vector OP, where P is 3, 4, and 12. So a point P is given to you, and you have to find the unit vector in the direction of this position vector. How do we do that? First of all, you have a point P, which is 3I plus 4j plus 12k. Okay, we find the magnitude. Why are we finding the magnitude? Because we know the formula for unit vector, which is magnitude of the vector divided by the unit vector, right? So unit vector is equal to magnitude of the vector divided by the vector itself, right? That is the formula for unit vector. So for that, you need to find the magnitude first. So for that point, which is a vector, from the point you make the vector, which is OP, then you find the magnitude of OP, which is root of 3 square plus 4 square plus 12 square, which is 9 plus 16 plus 144. You get 169. So root of 169, you get 13. So that's the magnitude, right? Now sorry, I said the formula in the opposite direction, in the opposite manner. It's basically the vector divided by the magnitude. So okay, so the unit vector is equal to OP unit vector. For OP you have to find the unit vector, right? So it is the vector OP, which is this, divided by the magnitude of OP, which is 13. So it will be 3I plus 4j plus 12k divided by 13, right? Now you will write it separately. So you will write 3 by 13I plus 4 by 13j plus 12 by 13k. So this is the unit vector in the direction of position vector OP. All right, that also a very simple question, also very important. Okay, therefore OP is in the terms, since the vector point, the question was in the point form, we write it in the point form as well. This is I will become on the x-axis. The first point is 3 by 13, then you have 4 by 13, and then you have 12 by 13. This is the unit vector. Again, for unit vector we have done one video, so make sure you check that out as well. If you have any doubts, it will be cleared. So because you need to understand what is a unit vector and why are we finding that unit vector for a particular vector. Okay, then question number 7. If a is 2 minus 3, so a will be 2 on the x-axis and minus 3 in the y-axis. Okay, find the vector. Okay, just wait, there is a mistake here. Basically it's 2 minus 3, so you are going to go in the negative y direction. Okay, so this is not in the upward direction, it's going to be here. So minus 3 is here, so your vector is going to be here. Okay, 2 on the x-axis and minus 3 in the y-axis. Okay, so this is wrong. All right, find the vector 3 OA and its magnitude. So basically it's a scalar multiplication. Okay, now 3 OA, how you will find that? OA is what? A is 2 minus 3, right? So it will be 2I minus 3j, right? You have to multiply a scalar with the vector. So the point is going to be 6, 3 2s are 6, 3 3s are 9. So 6 minus 9, right? Therefore, the vector that you're going to get is 6 on the x-axis, which is still here, okay? And then minus 9 on the y-axis. So let's suppose it comes somewhere here. So it will be like this. So this comes here, this comes here. Okay, actually you have to, but it's better that you make it properly. I'm just doing it because I made a mistake in the first part, so I'm going to just redraw it here in this manner, but you get the point, right? So it's minus 9 in the opposite direction. All right, so magnitude, then you will find the magnitude, because that also was asked from you, right? So OA will be magnitude of 3 OA, sorry, so it's 3 here, right? So the magnitude of 3 OA is under root of 6 square plus under root of minus 9 square. So that is 36 plus 81, which gives you root of 117. Alright, so I hope it was clear. There's just a slight mistake here, so don't get confused by that. Just make sure you look at the sign as well. It's minus 3, so it's in the negative direction, right? So it comes down, okay? It does not come up, right? So make changes here, and we have to find the magnitude of 3OA, right? So for 3OA, this is how you're going to do it. Okay, I forgot to write 3 here, so make that mistake, make that changes as well. Okay, next we have use position vectors to find a midpoint vector OM of segment AB, where A minus 2, 1 and B 4, 5. So first of all, you can make A, which is minus 2 here and 1 here. So this is A. Okay, this is point A, and B is 4, 5. So 4 on the X and 5 on the Y. So this is B. Okay, this is B and this is A. Okay, and then this one is AB. All right, what you need to do is you have to find the midpoint vector OM of segment AB. So you have to find the midpoint of this vector AB. Okay, the blue one, light blue one. You have to find the midpoint for that. How are we going to do that? First of all, OA is minus 2i plus j, OB is 4i plus 5j. Midpoint means what? Half of OA plus OB. What is OA plus OB? It's the, you will get the resultant, right, which is basically AB, right? So you have to get half of this. So it is going to be half of OA, which is minus 2i plus 5j, plus OB, which is 4i plus 5j. So you will get 1 by 2 of 2i plus 6j. Now you will solve it. So you multiply the scalar with the vector. You are going to get here, you get 2 and 2 gets cancelled, you get I, and 6 and 2 gets cancelled, you get 3j. So the point is 1, 3. Okay, that's your midpoint. Okay, so that's all for the intermediate questions. Now we move on to the advanced level questions. Let's see what's the first question here. Show that the points A 1, 2, B 3, 6 and C 5, 10 lie on a straight line using position vectors. If something lies on a straight line, it means that, so okay, before moving on to the concept, first of all we see that everything is in the positive, so there is no negative here, so everything is going to be in the first quadrant, right? You can draw them. A will be 1, 2, so this is A, then you have 3, 6, then you have 5, 10. Now you have to use the formula to prove that they are on the same line. So by same line we mean that they are collinear. Okay, this is a term used for some points that lie on a straight line. Therefore, these points are collinear. A, B and C. Now we know that the head to tail rule is what? AB is equal to OB minus OA. So it will be, so if you take OB, which is 3, 6, and then OA, which is 1, 2, when you solve it, you get 2, 3, 2, 4, right? Now if you take BC, which will be the resultant from OC minus OB, right? So it will be what? C is 5, 10 minus B is 3, 6. So you are also getting 2, 4. Therefore, basically, since AB is equal to BC, so the resultant of AB is equal to the resultant of BC, right? This means that they are on the same line, that is, they are collinear. Okay, this is the test. So basically what you need to remember is that you are going to use head to tail rule here as well for proving if the points are on a straight line. First 2 points you do the head to tail rule, then the second point and the third point also you do the head to tail rule. If the resultant of both of them are equal, therefore they are on the same line. Okay, so remember, head to tail rule is used here as well for the 3 points. So first 2 points and then the second 2 points. Okay, and if AB is equal to BC, that means they are on the same line. Okay. Question number 10. Given a line passes through points A, 2, 1 in the direction of vector D, 3, 4, write the vector equation of the line. What does this mean? That we have a line which passes through the point A, 2, 1. First you draw A, which is 2, and then 1. In the direction of vector D. Now a vector D is given to you, which is 3, 4. In that direction, a line passes through a point. Okay, write the vector equation of that line, the line which is passing through. Okay, how do we do that? First of all, you have A, which is the point A, 2i plus j, right? Now vector R, which is which we are going to say is a line which passes through, right, is equal to OA plus TD. So we assume that for making a line equation, that's how you make the line equation. Okay, this is the formula for the line equation, which is a vector which is passing through a point. So for what is the vector of that point? That is OA, right? That is a position vector. Position vector plus TD, because we are assuming that this R is a vector, right? That the line that's passing through, right? So we assume that in a generalized form we use an alphabet T, okay, with the direction vector which is given to us D. So this is a direction, okay. So the point through which the line passes added with the direction, okay. Now that direction with a generalized element over here that we're going to find out, okay. So OA is 2i plus j plus T, D is what? 3i plus 4j. So when you solve it, you're going to get 3ti plus 4tj, right? And when you add it, so you're going to get 2 plus 3t and 1 plus 4t by removing I and j, of course, right? It's basically 2 plus 3ti plus 1 plus 4tj. So you just write it in the points form because the question is in the points form, right? So this is the line equation for the line which is passing through a particular point, okay. Basically what you need to remember is you have to remember the concept, okay, concept of equation of a line, okay. When we have a point given to us and through that point a line is passing, okay, let's suppose that point exists over here, okay, and a line is passing through that point, right? So when we talk about that line, we have to write it in. Now the question is asking us that make the equation for that line, that line also exists in the Cartesian coordinate system, right? So therefore a vector equation must exist for it as well. So what is the formula for that vector equation? The formula for that vector equation is the position vector plus the direction. Now that direction will be a particular direction which we do not know at this point, right? So that is why we are going to take an alphabet here, that's T, so it's some value, okay, which will tell us that this is the direction in which that line is going. For now, we just know that we have a particular point and a line is passing through that point. It can go in any direction, okay, so we just assume T, that T is a direction, okay, and this is a direction vector, so that is 3, 4, all right. So the position vector plus T, D, okay. Use this formula and you can get the line equation. All right, so that's for this question. Okay, so now we move on to question 11, which is going to explain us how to find the value of t in the previous question. Okay, so in case that kind of a question comes, where you have to find the vector equation of a line, you do it till that point, and then you also have to find the possible values of t according to this question. So this is how you're going to continue that as well. All right, now we also look at this question from this point of view and another point of view. If the position vector of a point P is OP, like in the previous one it was OA, right? Now here the position vector of is given to us as OP, which is 2t and 3t. Okay, there we found the line equation of a given line which passes through a point which had the values t. Remember that. Now here you have 2t and 3t as the points, and P lies on a circle of radius 10. So this point P lies on a circle and the radius of that circle is 10, right? Centered at the origin. That circle is having the center at the origin O. Okay, so this is the origin O here. All right. Therefore, find all the possible values of t. Now, since the circle is having the origin O and the radius is R, okay, and since the circle is having the origin O, therefore the radius starts from the center, right, which is the center of which is the origin. So, therefore, this vector is going to be the position vector, because this is the point at which this is the point P which lies on the circle. So therefore this R is a position vector OP, right? So this is P here, right? So the position vector OP is basically vector R, which is the radius. Okay, now the radius given to us is 10. Therefore, the position vector, the magnitude of the position vector has to be 10, right? But we have to look at the point given to us as well, and basically we have to find the values of t. So what we are going to do is we are going to use the formula of magnitude, right, and then substitute that with the radius given to us. Why are we doing that? Because that's the most easiest way to solve this question by looking at it, because we see that OP is the vector and R is the radius, which is equal to the vector OP, right? Therefore, there is some common thing between them, right? So the magnitude of OP is basically equal to the radius of the circle. So we can use the formula of the magnitude in order to find the values of t. Okay, so let's see how we do that. First, the point P is 2t and 3t. P lies on the circle of radius 10 centered at origin 0, 0. Distance from origin to P is basically what? OP, magnitude of OP, right? Which is equal to the radius, right? Now for finding the magnitude, what is the formula? Root of x square plus y square, which is basically equal to the radius. So x is what? 2t and y is 3t. So it will be 2t square. So this is basically square, okay? Square here, not 2 like this. So it is 2t square plus 3t square, which is 4t square plus 9t square. Root of this will be what? Root 13, and t square will become what? Like this inside the mod. Okay, so it is mod t, root 13 mod t. All right, now this is equal to what? This is what we got, right? Root 13 mod t. This magnitude OP is equal to what? Equal to the radius, right? So therefore, root 13 mod t is equal to r, which is equal to 10, right? So therefore, mod t will be equal to what? 10 divided by root of 13. Therefore, when you remove the mod, it will be plus or minus. So it will be plus or minus 10 over root 13, which is the value of t. This is what we were supposed to find. Okay, this is how you find the value of t. Okay, this is the same way which you can solve the previous part also, where you have to find the values of t, right? Make sure this thing about the radius is also given, this thing about the magnitude is present there, because if you have the value of that magnitude, that which is the radius over here, then only you can solve the value of t in this manner. Okay, all right. We move on to the last question, which is given point A and B. Find the vector BA and its magnitude. Now, this is a tricky thing here. The question is very easy on its own. Just a trick here, because normally when you're given points A and B, they will ask you to find AB. That is the resultant vector. So you know the formula for the resultant vector AB is OB minus OA, right? Here they are asking you to find BA. So you have to do the opposite same thing. Instead of OB minus OA, you're going to do OA minus OB. That's the only difference. Okay, so make sure you read the question carefully and then you use the formula. So AB is OB minus OA, but BA is OA minus OB. Okay, so just do OA minus OB and this is what you get. And make sure to always make sure, because 1 mark is always going to get cancelled if you are writing, the question is in the points of form and you write in the vector form and you forget to write the points, right? So make sure you write the answer in the form of points as given in the question. If the question is in vector form, then you leave it here. But since the points are here, therefore you have to write in the form of points. Okay. And then they also ask you to find the magnitude. So magnitude of BA is using the magnitude formula, and there you go. You have the answer. Okay. So that's how you solve this question. The questions themselves are not difficult, they are very easy. Just have to make sure that you know the formula and use the formula. Most of the questions use head to tail rule. Certain differences are only in collinear points, where you are using head to tail rule, but you need to know how to use it. Also for midpoint you have a formula, for vector equation of a line you have a formula. These are the few things that you need to remember. Okay, so that's all for the position vector exercises. If you have any more questions related to position vector, you can comment down below. And next up, we're going to talk about scalar product, cross product, scalar triple product, cross triple product, and so on. So those topics are also seen in past paper for CSS. So we're going to solve those questions as well. So make sure you stay tuned for the next video. And that's all for today. Take care. Bye bye.